Today we're going to solve exponential equations. Now to solve exponential equations, to solve any equation, what you do is you apply the inverse operation to your equation until you get down to your final value. So if you think of it, if we start with an exponential, you got to think, what is the inverse operation of, or what is the inverse of raising something to an exponent? And the inverse is actually the logarithm. So we're going to have to use logarithms to solve exponential equations. And there's a bunch of different types, so I'm going to run through a couple of types, and then we'll definitely practice more in class together. I have the steps, and I have an example to go along with the steps. We have 5 plus 3, and here's my exponent to the x plus 2, and that's equal to 12. So we will start with the first step. The first thing you want to do is isolate the exponential expression, and what I mean by that is, here's my base, here's my exponent. I want to get this guy by himself on one side of the equation. So looking at this, I got to get rid of the 5. To get rid of the 5, you just subtract it away, and you're left with 3 times x plus 2 is equal to 7. So now if I want to solve this equation, I've got to get my variable down from being an exponent. So this is where I use the inverse operation. I'm going to take the log, the common log, or the natural log of both sides. Why common log and why natural log? Because those are the two that are definitely in your calculator. So those are the two you use. Either or, it doesn't matter which one. I guess for starters, I'll just take the common log of both sides. So that would be the log of 3 to the x plus 2 is equal to the log of 7. So now that I take the log of both sides, I can use the third law to bring the exponent down in front. So that's what I'll do. I have x plus 2 times the log of 3, and that's equal to the log of 7. Finally, once my exponents are down, we're going to solve for the variable. And sometimes this is the hardest part for kids because you have a difficult time dealing with the logarithms. Log of 3, this is just a number. And this is just a number, but we are not going to put those in our calculator yet. I want you to keep these exact, meaning I want to represent the log, the common log of 3 and the common log of 7. And deal with them a little more algebraically than just putting in a number and rounding and stuff. We don't want to do that. So, to get my x by itself, you could either distribute the log, or I can divide both sides by this log of 3. So if I divide by log of 3, I'm left with an expression on the right-hand side, and on the left-hand side, I'm left with x plus 2. That's equal to the log of 7 over the log of 3. It's just a number, so we're just going to leave it like that. Finally, my exact value of x, if I subtract away the 2, is log of 7 over log of 3 minus 2. That's my exact answer. At that point, you can find the approximate answer by substituting in. This is when you get your calculator out. And we usually round our answers to 4 or 5 decimal places, but x is approximately negative 0.22876. So you do all the work algebraically and solve for the exact answer, and then at the end you can give me the approximate answer, but I'm more interested in the exact answer than the approximate. So let's take a look at our second example here. I have 8e to the 2x, so this is my exponent, plus 3 is equal to 23. The first step is to isolate the exponent, the exponential expression, which is just e to the 2x. So I got to subtract away the 3, and then I'm going to divide the 8. Subtracting the 3 leaves me with 8e to the 2x is equal to 20. And then if I divide by 8, I get e to the 2x is equal to 2.5. Now in this case, at this point, you're either going to take the common log or the natural log. But looking at this, really, which one should you take? And everyone should tell me why I should take the natural log, because it's going to be a lot easier. When I have a base of e, I want to take the natural log because that's going to simplify it. So I have the natural log of e to the 2x is equal to the natural log of 2.5. I bring my exponent down, and here's why I chose natural log. Whoops, that's a funny looking 5, sorry. This is a property. The natural log of e is equal to 1. So that makes things a lot easier. I have 2x is equal to the natural log of 2.5. My exact answer is the natural log of 2.5 divided by 2. That's my exact answer. That's the one I really want. And then if you put that in your calculator, you'll get a value x is approximately equal to 0.4581. Now sometimes you can make an exponential equation a lot simpler, much simpler, because you can get a common base. A common base means I can rewrite the base in terms of another one. So if I look at 2 to the x minus 1 and 4 to the x plus 2, the larger base can be rewritten into the smaller base. That's not always the case, but you always change the larger base if you can do it at all. So I have 2 to the x minus 1, and instead of writing 4, I'm going to say that's 2 squared. And then that little 2 is multiplied by x plus 2. When you have common bases, you can set the exponents equal to each other. So that makes it a lot easier. Now I know you solved these last year. X minus 1 is equal to, I'm also going to distribute 2x plus 4. And then it turns into a really simple problem. If I subtract 4, I get negative 5. If I subtract x, I get x, and x is negative 5. I don't even need an approximate answer. The exact and approximate are the same. So when you can write things in terms of a common base, that will work. But you have to be careful. You can do, like if you have a 3 and a 9, you could rewrite the 9, right? Because that's 3 squared. If you have, I don't know, a 4 and a 16, well, this guy would be 4 squared. But be careful, if you have like a 2 and a 6, you can't do it. You cannot rewrite those. So only when you have multiples of 1 can you do that. We're going to finish one that is a little bit more work and a little bit more algebraically intensive. I have 3 to the x plus 2, and that's equal to 5 to the x minus 1. I can't get common bases. 3 or 5 is not a multiple of 3. So the only thing I can do here is to take the log of both sides. Let's do that. I'll just use natural log, just because it's fewer letters I got to write. Natural log of 3 to the x plus 2 is equal to the natural log of 5 to the x minus 1. Now I'm going to use the third law, and I'm going to bring my exponent down in front in parentheses. Actually, I should probably put parentheses in these right now so I don't forget. If you forget anything, it's going to be that, and I will take points off. You have to put the binomial in parentheses because the entire thing is being multiplied by the natural log of 3. So this is what I want to see. In parentheses, x plus 2 times the natural log of 3 is equal to x minus 1 times the natural log of 5. This is where kids get stumped because it looks, you know, you got x's on both sides. They're both embedded in the binomials. You got the goofy natural logs or the goofy logs of these numbers. But this is really a first degree equation. Natural log of 3 is just a number. Same with natural log of 5. So if that were a regular number here, you would distribute. Well, that's what I want you to do. I want you to distribute natural log of 3 into the parentheses. And I want you to distribute natural log of 5 into the parentheses. And here's what we get. We get x natural log of 3 plus 2 natural log of 3. And on the other side, we get x natural log of 5 minus the natural log of 5. Again, it's a first degree equation. So when we solve a first degree equation, I'm going to move anything with an x to this side by subtraction, and anything without an x to the other side by subtracting it away. So when I do that, I'm really subtracting x natural log of 5. I can't combine it with anything. I'll try to do this in a couple steps. X natural log of 3. I keep making an h instead of an ln, and it won't let me erase. Let me try that again. So I end up with x natural log of 3 minus x natural log of 5. And I'll keep the 2 natural log of 3, and on the other side it's negative natural log of 5. Now I'm going to subtract the 2 natural log of 3. And I'm left with x natural log of 3 minus x natural log of 5 is equal to, these are both subtraction. All right, so let's talk about where we go from here. So here we have our equation. Again, it's a first degree equation. I've got two x's here. I really need to get it to a single x variable, and then I can solve. So I can't really combine like terms because I can't add natural log of 3 to natural log of 5. But what you can do to create a single x is I'm going to factor an x out of these two terms. So if I factor a GCF of x out, I'm left with the natural log of 3 minus the natural log of 5 as an expression. And then over here it's the natural log minus 2 natural log of 3. And I'm only one step away from solving it because all I have to do is divide all this stuff away and x is by itself. So in the end you end up with x is equal to the numerator negative natural log of 5 minus 2 natural log of 3 all over the natural log of 3 minus the natural log of 5. Now your signs might change if you moved everything to the other side. That's okay. But in the end, your approximate value should be the same. You've got to be very careful when you enter this in your calculator, but you should get approximately 7.452 when you're done. This is the exact answer, and then this is what you do at the very end when you put your values in your calculator. So we're going to work more on this in class because the more you practice it, the better you're going to get. And so that's what we'll do in class tomorrow.